Lesson 3.2 is looking at some examples of winning streaks at West Ottawa High School. One of the most successful teams in the history of West Ottawa sports is the men's swim team. They have actually won 9 consecutive OK Red titles, and they won all of those from 2014 up to 2022. They have 5 state titles and were state runners up 6 times. The last time they had a loss in a dual meet was way back in 2014. In your notes, you have the results of all of their seasons from 2012 through 2021. And what we want to look at here is this evidence that the West Ottawa High School men's swim team has a hot hand? In other words, are they a streaky team? What we're going to do is, first of all, start by stating our hypotheses. And you may remember from the last lesson that with tests for winning streaks or losing streaks, our null hypothesis is that the outcomes are independent. So in this case, we would say the outcomes of the West Ottawa men's swim meets are independent. Our alternative then is that they are a streaky team. Now, our test statistic in this case is going to be the length of the longest streak. And if you continue a streak from one season to the next and you go back to that list of wins and losses at the top of your notes, their longest streak is 65 wins. Now, we're going to use an applet in this chapter called the Streaks applet. And you need to type all of the results of those swim meets into the box where it says observed sequence. But instead of using wins and losses, you need to enter them as successes and failures. And they must be entered lowercase. You don't need to put any spaces or commas or anything in between. And then we're going to use the applet to do 100 trials of the simulation. So this is what the applet looks like when you first click on that link. The box at the top where it says observed sequence is where you're going to type the successes and failures. You can use this button here that says compute the longest observed streak to actually count that longest streak for you if you don't want to type it in. And then you're going to type in 100 in this box and click on the add more trials button. So when you're done typing it in and you click the add 100 trials button, you're going to get a dot plot simulation. And it's going to do the same thing that we did with the cards earlier in this chapter. But it's just saving you a lot of time rather than dealing out all of those cards. So you can go ahead and sketch that dot plot in your notes. And notice that in your notes, the scale is not labeled there. So you can go ahead and label that in any way that you'd like. Now, the next question they're asking you is to estimate the p-value and make a conclusion. So here's your dot plot. Now, our test statistic, remember, was 65 because that is the length of the longest streak that the men's swim team had. And you can see from the simulation that we didn't get any streaks longer than 61 when we did this. So our p-value would be how many results of those 100 trials were at 65 or greater. And there are none since our longest streak in our simulations ended up being 61. So that means our p-value would be 0%. And because that is less than 5%, our conclusion then would be to reject the null hypothesis. And this is very good evidence that the men's swim team is a streaky team. Now, the next question in your notes asks, according to the results, how many wins in a row would the swim team need to have to be convincing evidence that they do have a hot hand? In other words, what length of streak would give us a p-value small enough that we would reject our null hypothesis? So let's go back and look at that dot plot again. And we know that with a test statistic of 65, we rejected the null hypothesis. And so what we're interested in is looking at how far this direction can we go where we would still reject the null hypothesis. In other words, how short could their streak be where we would still consider them to be streaky? And the way that you can do that is kind of working your way back from the right side of the graph because long streaks are good evidence that they are streaky, but we want to know how far back could we go before we would say, all right, at this point, we would fail to reject our null hypothesis and we don't have good evidence that they're streaky. Well, you may notice right here, this is where our first dot appears. So at a streak length of 61, our p-value would be 1%, and we would still reject the null hypothesis. If we had a streak length of 59, there our p-value would be 2%, right? Because we would have 2 dots above that point, and 2% we would still reject the null hypothesis, and they would be considered a streaky team. So we want to count backwards, and we can go as far back as right here, because that's the cutoff, where anything to the right of that is 4%, which would mean we would reject the null hypothesis. But if we go down one more, then our p-value would be at 5%, which is fail to reject. So this value right here is the smallest streak they could have and still be considered streaky. And that looks like 51, 52, 53, 54. So any streak of 54 or larger would lead us to reject the null hypothesis. A streak of 53 or smaller, which are all the results this way, would lead us to fail to reject. So anything 54 or greater would lead us to reject the null hypothesis. All right, please do homework 3.2 in your assignment packet.